Okay, so let's look at this problem. So I used the last time I taught this class, I used slightly different notation. So let me just explain what some of this stuff means here. I mean, you probably get what I'm trying to say here, but really what I'm saying, so really what this means is the coordinates of V1 relative to the elementary basis are 1, 0, 1. And the coordinates of V2 relative to the elementary basis are 0, 1, 1. And the coordinates of V3 with respect to the elementary basis are 1, 1, 1. Okay, that's what I mean by all of this right here. Okay, now what the problem asks us is given V, we know the coordinates of V relative to the E basis. So similarly, what this tells us is the coordinates of V relative to the E basis are 2, 1, 3. What we want to do is find the coordinates of V relative to the B basis. And so remember, the change of basis matrix from E basis to B basis is just this matrix inverse. And we're going to multiply it by the E coordinates. Okay, what are the E coordinates? It's just 2, 1, 3. So we first need to figure out the linear transformation. We first need to figure out the inverse of this matrix. 1, 0, 1, 0, 1, 1, 1, 1, 1 times, I'm skipping ahead. Got to augment this with the identity matrix and row reduce. So I'm going to first subtract row 1 from row 3. So 1 minus 1 is 0, 1 minus 0 is 1, 1 minus 1 is 0, 0 minus 1 is minus 1, 0 minus 0 is 0, 1 minus 0 is 0. Okay, now I'm going to, so I don't have to keep moving down. I'm going to subtract row 2 from row 3. So 1 minus 1 is 0. 1 minus 1 is 0. 0 minus 1 is minus 1. Minus 1 minus 0 is minus 1. 0 minus 1 is minus 1. Okay, and then the 1 stays the same. 1 minus 0 is 0. Now I'm going to multiply row 3 by minus 1. So these minus signs go away, and then we add 1 to that. And I'm going to say row 2 is equal, now I'll go ahead and copy everything down. Row 2 is equal to row 2 minus row 3. 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 1. 0 minus 1 is minus 1. 1 minus 1 is 0. 0 minus minus 1 is 1. And the bottom row stays the same. 0, 0, 1, 1, 1, minus 1. And now I'm just going to subtract row 3 from row 1. Okay, so 1 minus 1 is 0. 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 1 is 0. 0 minus 1 is minus 1. And 0 minus minus 1 is 1. Okay, and so that's the change of basis matrix. So now I'm going to erase this. Okay, so this is 0, minus 1, 1, minus 1, 0, 1, 1, 1, minus 1. And now I'm going to multiply by the coordinates of V relative to the E basis, which is 2, 1, 3. And what I'm going to get is, let's see, minus 1 plus 3, that's 2. Then I'm going to get minus 2 plus 3, that's 1. And then at the bottom, it's 2 plus 1, which is 3 minus 3, which is 0. So it looks like this is the correct answer. Notice we can check our answers. So we know the coordinates of V relative to E are 2, 1, 3. So these are the coordinates of V relative to B. So it's saying that V should be equal to 2, or really the coordinates of V relative to the B basis should be 2 times the V1 plus 1 times V2. and this is equal to 2, 1, 3, which checks out. And of course, we have the correct answer there. Okay, the next question is to determine the matrix of L relative to the basis B. Well, these are the vectors v1, v2, and v3 are eigenvectors. Okay, the vectors v1, v2, and v3 are the eigenvectors. So we could compute the d equals v inverse thing. I mean, that's one thing that we could do. But notice that the whole point of, not the whole point, but one of the main things about dealing with eigenvectors is that the matrix, that if you have a basis of eigenvectors, then the matrix of a linear transformation relative to the eigenbasis is just going to be a diagonal matrix where the corresponding eigenvalues are on the diagonal. Okay, so we know the answer choice isn't A because that's not diagonal, and the answer choice B is not diagonal. So you know what? So I remember now. There's actually not a correct answer choice for this one. So this, that one there should be a 0. So this one should be a 0. Okay. Anyways, so we know that A can't be it because that's not diagonal. That's just the matrix of eigenvectors. Okay, so that's not it. That's the change of basis matrix. Okay, now don't get confused. Both B and C are diagonal, and it has the eigenvalues on the diagonal. But remember, a basis is an order. It has v1, v2, v3. So the basis v1, v2, v3 is different from v2, v3, v1, for example. Or it's different from the basis of, v2, v3, v1. So this would be like the matrix relative to the basis v2, v3, v1. But the basis is v1, v2, v3. That means that needs to be the eigenvalue corresponding to v1. That needs to be the eigenvalue corresponding to v2. That needs to be the eigenvalue corresponding to v3. Or a little more generically, this is the eigenvalue corresponding to the first vector in the basis. That's the eigenvalue corresponding to the second vector in the basis, and that's the eigenvalue corresponding to the third vector in the basis. And so answer choice B is the correct answer choice for this problem. Okay, now let me see if there is let me see if there's a question using this on the next page. Nope. Okay, so that's all I'm going to do for problems 8 and 9 in this video.